Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the derivatives from the left and from the right at x equals 1 if they exist of the following functions. Are the functions differentiable at x equal to 1? So in this video and the next couple of videos, we will take a look at how to examine differentiability of a function at x equals x naught, right? So drawing your attention to the conditions for differentiability, which I have put it up on the right of our screen. So, like we saw in our previous video, a function is differentiable at x equal to x naught only if f dash, which we call it as the derivative of x naught plus, and f dash of x naught minus both exist and both are equal, right? So, what is my f dash of x naught plus? It's nothing but my right hand derivative. My f dash of x naught minus is my left hand derivative, right? So a function is differentiable at a particular point x equals to x naught only if the left hand and the right hand derivative both exist and are equal at that point x naught, right? So what we've been asked to find in this problem is find the derivative and then confirm that if the left and right hand side derivatives are equal, and if they are equal, we can comfortably say that the function is differentiable. If they are not equal, then the function is not differentiable, right? So let's take a look at the function and see how to go about solving the problem. So f of x mod of x minus 1 is can be written like this, right? And my mod of x minus 1 is nothing but it is x minus 1 for all x, right? Sorry, greater than or equal to 1, and it is minus of x minus 1 all x lesser than 1, right? And what is my minus of x minus 1? I think I can comfortably rewrite this as 1 minus x, right? So this is the function, and we've been asked to examine the differentiability at the point 1. So what is our x naught? Our x naught is equal to 1, right? So let's write down the left hand and the right hand derivative. So this is my right hand derivative. If I can call it RHD, f naught of x naught plus can be written as limit h tending to 0, f of x naught plus h minus f of x naught divided by h, right? And what is my x naught? I've been asked to find the differentiability at 1, so I can write this as f naught of 1 plus. What is my f at 1 plus h? And what is my f of 1 divided by h, right? Now we know how to solve this problem. It is not very difficult. And what do we mean by 1 plus h, right? 1 plus h is actually greater than 1, right? So when I rewrite this particular equation, which is that f of x I will have to take? I will have to take this one, right? For my right hand derivative, let me highlight it in yellow. So when I write that, my f of 1 plus h is nothing but my f of 1 plus h is nothing but 1 plus h minus of 1, right? I'm using the x minus 1 function, and therefore, and what is my f of 1? My f of 1, I will have to pick up the function again, which is highlighted in yellow, because f of x equals x minus 1 for both x greater than 1 and x equal to 1, right? So what is that? That is 1 minus 1, right? 1 minus 1, which is nothing but my x minus 1. I have written that as 1 minus 1 divided by h, right? So now what happens to this? My first part 1 and minus 1 get cancelled, and I'm left with h by h, right, which is nothing but my 1, right? Limit h tending to 0. So this is my RHD. Now let's move to my LHD, right? LHD, so this is my LHD, f dash of x naught minus equals limit h tending to 0, f of x naught minus h minus f of x naught divided by minus h, right? So now my x naught is 1 here. So all I can do is replace my x naught by 1 and f of 1 minus h minus f of 1 divided by minus h, right? And now this time my x, right, is going to take a value 1 minus h, right, which means it is lesser than 1, right? So which is that function I will have to apply when x equals 1 minus h, right? I will have to apply this particular function, right? So I'm going to rewrite this in the next line. And when I do this, I have my f of 1 minus h as 1 minus 1 minus h, right? 1 minus 1 minus h. And then I have my minus of f of 1, which is means that my x equals 1. I still go to my first equation, which is x minus 1, because that's the equation we have whenever x equals 1. And I write that as f of 1 equals 0, right? We have established that while doing our RHD, right? And I have my minus h in the denominator. Right? Now what do I have is I'm left with a h in the numerator and I'm left with a minus h in the denominator, right? Because my 1 and 1 gets cancelled and I'm left with h and minus h in the denominator. So which means my h divided by minus h equals minus 1, right? So we have our RHD. Let me call this out again here. My RHD is plus 1 and my LHD is minus 1, right? So my RHD and LHD are not equal, right? So I can straight away confirm that though my RHD and LHD exist, right, the function is not differentiable at x equals 1 because my LHD not equal to my RHD, right? RHD, right? That's how we go about solving problems when we examine differentiability of a function at x equals x naught, right? For a function f of x. So I hope you liked my video and found this content useful. Please do subscribe to my channel and support. Thank you.